All right, let's get started. I'll give your exams back at the end of class. If you want. All right, let's get back to our alkynes. Let's see if we can finish up the chapter. Okay, let's look at how to make alkynes. Okay. What we do is we start with a vicinal dibromide. And react with what's called fused KOH. It just means it's heated together. Okay. So a vicinal dibromide, remember, is this setup here. Okay, remember that vicinal means neighbors, so the two bromines are on neighboring carbons. Okay? And we're reacting this with fused KOH, which basically acts as OH minus. And what we end up getting is a double elimination reaction. You see? Takes beta hydrogen, forms a double bond, kicks off. And then another one comes in, forms another bond, kicks off, so you get a total of a triple bond. Okay? So kind of symbolizing that there. 1, 2, 3 gives you the double, and then it comes in again to form the triple. Okay? So that is our primary way of making an alkyne, or the triple bond. Okay. Let's take a look at some examples. Okay, so here we have the two bromines in the middle. And that gives us the internal triple bond. Okay, so make a note of it. Wherever the two bromines are, plus fused KOH, the triple bond forms between those two carbons there. Okay. Okay, well, let's move on then. And look at some reactions of alkynes. Okay? And these are going to be addition reactions. Okay? Remember that double bonds underwent addition reactions. If you look up here, somebody didn't write Zays's rule right here. What's wrong with that? It's an elimination reaction, not an addition. Okay. Well, alkynes can undergo addition reactions. And if you look on your outline, we're going to look at a series of them. Okay, the first one we're going to look at are hydrogenation reactions. Okay, remember in hydrogenation we add hydrogen to the multiple bond. Okay, and there's three hydrogenation reactions we'll look at. Okay, the first one will be two equivalents of hydrogen and platinum. And what this will do is fully saturate the triple bond. Okay? So if it fully saturates the triple bond, what's it going to convert the triple bond to? A single bond, just like if you saturated a double bond. Okay? So let's take our alkyne that we just formed. And react with two equivalents of hydrogen. So here we have a total of 4 hydrogens that will add across there to fully saturate to the alkane. Okay. So here's our 4, 2 here and 2 here that have added. Okay. So you can see kind of a synthesis. If I started with this dibromide, I could make the triple bond, and then I could saturate to make butane. Okay. So there's a nice 2-step synthesis to go from here over to here. Okay. But here, since we have a triple bond, there sets up 2 other hydrogenation reactions to look at as well. Let's look at those over here. Okay, and these are going to be what are called partial saturation. Okay, so if I have a partial saturation, what do you think the triple bond will go to? A double bond. Okay, and there's 2 of these. The first one is with hydrogen and palladium barium sulfate. Okay, what this does is it saturates the triple bond to a double bond, and it makes the double bond cis. Cis. Okay. Let's look at an example. Okay, so let's stick with our 2-butene and do the reaction. Here you would get the cis double bond. Like that there. Okay, so it's a partial because I've gone down to the double bond. and it leaves it cis. What do you think the other kind of partial saturation is? To get the trans double bond. And to get the trans double bond, we use this ingredients, sodium and ammonia. To get the trans. Okay. So let's stick with our 2-butyne to do this. As you look at these ingredients, this is the only one that doesn't have H2. Okay, what happens is this combination generates hydrogen to add to the triple bond. Okay. And so we end up getting the trans double bond there. Okay. So we start with the same alkyne in each case, but in each hydrogenation, we got a different product. We're fully saturated, the cis double bond, and the trans double bond. Okay? So be putting your reagents on note cards to help you keep these straight. Okay? Any questions on these hydrogenation reactions? Okay, let's go to our next addition reaction. Okay, our next one is with bromine or chlorine. Okay. Remember this reaction with double bonds? How did these add to double bonds? Okay, you had a whole mechanism.
Anti.
They added anti to each other. Okay. So let's do an example. Let's stick with 2-butyne. And if we add one equivalent of bromine, it adds anti to the triple bond to convert it to the double bond. So if it adds anti, those two bromines will end up how? Trans to each other. Okay? So they end up trans to each other because of that anti-addition. Okay? But if you note, that takes it down to the double bond. You could then do what? React it with another Br2. See that? took it and reacted with another equivalent of bromine, then we'd have a total of 4 bromines where the triple bond was. So to summarize that, okay, how do you know which one you're going to get? This is the way you know. If I react with 1 Br2, I get the trans. If I react with 2 Br2, then we get that thing there. Okay, so that's how to keep the 2 reactions straight. Okay, just make a note of it. 1 goes to the double bond, which is trans. 2, I then had 2 times 2, 4, all to that triple bond. Okay. All right. Well, this next one we're going to do will be the one today that we'll need to study the mechanism. So let's spend a little time with this one. And here we're going to react the triple bond. With HCl or HBr. So let's stick with our 2-butyne. And let's choose HCl. Okay. So remember when I said you had a double bond, those pi electrons, I told you to draw in with a gigantic lone pair. We'll do the same thing with a triple bond. So this lone pair can attack the hydrogen. So one carbon gets the hydrogen, the other gets the positive charge. And then the chlorine comes back. Attacks like that. But let's do the same thing again, but let's change our alkyne to this thing here. Let's do the same reaction. Okay, so a pi bond attacks the hydrogen. this time, you have to make a choice which carbon gets the hydrogen. Which of these two do you think will get the hydrogen? The middle one or the outside?
The outside.
Why the outside one?
Carbon gas.
So you get the more stable carbocation. Which is following what? What rule? Mark. There's Mark. Somebody forgot what Mark was. Okay? So here, this follows Markovnikov's rule, just like double bonds did. Okay? So the more substituted carbon gets the positive charge. And so the chlorine in that attack to get there. But suppose you brought in another HCl. Could another HCl attack? Now I got a double bond. So if I reacted with HCl, it could do it again. So it would follow Markovnikov's rule again. So the more stable carbocation forms. And then the chlorine would attack it. So you get the 2,2-dichloropropane. Okay, so make a note of it here, that this follows just like the previous reaction. If I use one HCl or HBr, it stops at the double bond. If I add a second equivalent of HCl, then it does it again to give you the two halogens on the same carbon. Remember what that's called? Not vicinal, but what? Geminal. Okay, so vicinal means neighbors. Geminal means they are on the same carbon. Just a relationship. Any questions about this mechanism here? In this chapter, there are only two mechanisms you need to know. One is this one, and the other, if you look on your outline sheet, is back up in number 2 and 3, dealing with taking off the acidic hydrogen on the triple bond. Okay? Remember we did that last time with sodium amide to make the acetylide ion. Okay? So those are the only two mechanisms of the chapter. Okay, let's do another reaction. Again, over the weekend, put these on cards so you keep them straight. But you're going to have another sheet of reactions like you did on this last exam, where you missed a lot of them. Told you what was coming, you still missed it. All right, let's now look at a triple bond plus mercury sulfate and sulfuric acid. Do you remember what this did to a double bond? Anybody remember that reaction? We converted the double bond to what? To a carbonyl. Remember, you got the internal carbonyl and the external carbonyl. Okay? So converts one of the carbons to a carbonyl. Let's take a look at an example. Okay. So the trigger should be when you see the mercury. It's going to convert one of these two carbons to the carbonyl. Which of these two carbons will it convert? The middle one, the more substituted one. Okay? So it's almost like called a Markovnikov. Okay? So make a note of it. The mercury, remember how I told you to remember it? Mercury always takes the middle carbon atom, MM. Okay. If you wanted to do the reaction so the other carbon got the carbonyl, do you remember what reagent you used for double bonds? It's kind of that messy one. Remember? Silyl, amyl, all that mess. Okay. All right, well, let me remind you. Okay, is this set up here, where now it converts the end carbon to the carbonyl. To give you the aldehyde. Okay. I didn't ask those on the last exam. Okay. But the mercury does the middle one to give you the ketone. The silyl amyl boron does the end carbon to give you the aldehyde. Okay? So put these things on index cards. Not requiring you to do any mechanism. Just know how to write the answers. Well, that sets up two more reactions in the chapter, and then we're done. Okay? And these are going to be what are called oxidation reactions. Oxidation reactions of the triple bond. Okay? So the first one that we'll look at is Kmno4 and water. Okay. Remember, potassium permanganate is a strong oxidizer. It's going to oxidize these two carbons to carbonyls. Okay. So you see how that's an oxidation reaction, because now I've added two oxygens and two double bonds. Okay. Let's look at an example of this. What would you do in this reaction here to get the product? Why don't you come up and draw the product? Purple.
Me?
Draw it right here. How many think she's right? Well, I think she's right. So she gets a check mark, not an X. Okay? So just go to the triple bond and put two carbonyls there. Okay? One other oxidation reaction. Okay, this one's a little bit stronger. Let's do an example of this. Okay, this one is going to be a two-step reaction where we react with Kmno4 and base, and then secondly, H+. Okay? This here will be a cleavage reaction, okay? Where we're going to cleave the triple bond into two fragments. Okay? And the two fragments will be each carbon gets an acid group. Okay? So let me draw the products down here so you can follow. Okay? So that side gets an acid group. And this side gets an acid group. Okay? So it's an even stronger oxidation, because I'm adding an extra oxygen there. Okay? So, powerful reaction. Okay? So those are the two oxidation reactions you want to remember. Any questions on either of them? Okay? Just remember, this one's two-step with base and acid. This is just one step with the water. Okay? All right, so that finishes up Chapter 9 on alkynes. On Monday, we'll go ahead and start up Chapter 10 with alcohols. Let me go ahead and hand back your exams.